let's try to solve another Leetcode problem. 2389, longest subsequence with limited sum. So we are giving an array of nums, and we are also having an array of query. And the subsequence of an array is that we just need to delete one or more elements from the array without changing the order of the remaining elements. So this is the meaning of the subsequence. So basically it means we can take any numbers from the nums, and we need to return an array answer of length m. So the length m gonna be equal to the length of the query. So where answer I is the maximum size of the subsequences that you can take from nums. So for example, for the first query 3, the maximum elements so we're gonna take is 1 and 2. So it's gonna be 2 elements. So that is why we're gonna have an output of 2. And what about 10? And we can have 1, 2, and 4. So we're gonna have 3 elements. And what about 21? So we're gonna have all the elements. So it's gonna be 4. So according to the example, as you can see, this is like a greedy idea. So first of all, we need to take the numbers as small as possible. So for example, for each of the queries, we're gonna take the numbers from the smallest to the biggest numbers. Because if we take the big number first, maybe we can take less numbers. But if we take the small number first, maybe 1 to 2, and we can take more numbers. So this is the idea. And another one is that if we take each of the numbers, so basically it is the sum of all the numbers. So this means we can also use the prefix sum to solve the problem. So for example, if we just take numbers like 1, 2, 4, and 5, and also for these numbers we can use the prefix sum to sum up all of them. So we're going to prepare a padding 0. It's going to be 1, 3. Here gonna be 1, 3. Here gonna be 7, and here gonna be 12. So first of all, we're gonna sort the nums, and then we're gonna prepare the prefix sum because we're gonna use the binary search to solve the problem. So binary search with prefix sum. So for example, for the first query about this 3, so it will be in this position. So the index gonna be 2. So we're gonna just put 2 inside. So the index is just the number of elements. So what about 10? So if it is 10, it's gonna be at this position. For the binary search, we're gonna use the bisect left. So the index is gonna be 0, 1, 2, 3, 4. But we should know that the numbers should be 3 because this 10 is bigger than this 7. Basically, if this 10 is not equal to the current element, if it is equal to the current element, it is okay. We just take the index. If it is not equal, 10 not equal to 12, so we're gonna take the index minus 1. So 4 minus 1, it's gonna be 3 elements. So this is why it is 3. So for the last one, 21. So for 21, so for the index, it's gonna be here. 21, it goes out of the range. If it goes out of the range, it's also the same. So we're gonna use the index minus 1. So it's gonna be index 4 because here is 0, 1, 2, 3, 4, 5. So it's going to be 5 minus 1. So it's going to be 4. So this is how to solve the problem. Now we're going to use first of all, we're going to sort the nums, and then we're going to use the prefix sum. So it's going to be the list accumulate with the nums, and we're going to prepare an initial going to be 0. Now we want to prepare all the answers. So it's going to be 0 times the length of the queries. Now we can enumerate the queries. So for Leetcode, enumerate the queries. We want to check each of the results. So we're going to prepare a j as the bisect position. So we're going to use the bisect left with the prefix sum array. And we want to check this query. So if this j is less than the length of the array, prefix sum array, and also the aj equal to our current query equal to this q, it means we've found the position. So it's going to be result I equal to j. So if it is not, this means it can be go out of the range of the binary array, it means it equal to the length, it goes outside, yeah. Or it can also be not equal to the current number. So if it is like that, so the result I would be updated to z minus 1. So it's gonna be one position before the current index, this j. So finally, we just need to return the result as our query. As you can see, it works. Now let me submit it to check if it can pass. As you can see, it passed all testing cases. Now let's analyze the time complexity. So for here, we enumerate the queries. So this is gonna be m, and for here is a binary search of the length of the array. It's gonna be n. So the time complexity gonna be m times log n. So this is gonna be the final time complexity. As you can see that even this m, it's gonna be 10 to the power of 5. It is still okay. Or even this for this number n. So for the length of the array, even it can be 10 to the power of 6. It is also okay. Yeah. So this is why we're gonna use the binary search to solve such kind of problem. Thank you for watching. See you next time.